Welcome to Ask and Learn.
So this question, we're given about nine graphs, and we are asked to select the graphs that best matches the numbered manufacturing cost data and indicates by letter which graph best fits the situation described. And the question is, the vertical axis of the graph below represents total cost, horizontal axis represents units produced. So vertical axis represents total cost, horizontal axis represents units produced during a year, and in each case, the 0 point of dollar and production is at the intersection of two axes. So at the intersection, at the intersect is where we have the 0 point of dollar and production. So now we have like around nine graphs, and we select the graphs that matches the best the numbers of each questions basically. So I think I'll just be drawing the graph. So graph A looks like this. They're really small. Graph A looks something like this. I mean, the graph should be in the book, but I just want, make it easy. Graph B looks like this. Something like this. Graph C looks like this. Graph C looks like this. Graph D looks like this. Graph E looks like this. That's graph E. Graph F looks like this. hmm Graph G looks like this. And H looks like this. I looks like this. J looks like this. K looks like this. And L looks like this. So these are the graphs, and then we have a list of questions. So the first question, which is A, which is one, annual depreciation of equipment where amount of depreciation charge is computed by the machine hours method. The graph that matches in the this one is graph K because it's an annual depreciation of equipment and the amount of depreciation is computed by the machine hours computed. So that's K. The second question, electricity bill of flat fixed charge plus a variable cost after a certain number of kilowatt hours are used, in which the quantity of kilowatt hours used varies proportionately with quantity of units produced. For this one, we use graph B. Question C. The city water bill is computed as following, with the first, next, and so on gallons and the flat fee used. And the gallons of water used vary proportionately with the quantity of production output. And for this question, we're going to use graph G rather. For number 4, the cost of direct materials, where the direct materials cost per unit produced decreases with each pound of material used. For example, if 1 pound is used, the price is $10. If 2 pounds are used, the price is $19.98. If 3 pounds are used, the price is $29.94, with a minimum cost per unit of $9.20. For this question, graph J is used. For number 5, annual depreciation of equipment, where the amount is computed by a straight line method, where the depreciation schedule was prepared, it was anticipated that the obsolescence factor would be greater than the wear and tear factor. For this question, we use graph I. For number 6, the rent on a manufacturing plant donated by the city, where the agreement calls for fixed fee payment unless 200,000 labor hours are worked, in which case no rent is paid. For this question, we're going to be using graph L. The next question, salaries of repair personnel, where 1 person is needed for every 1,000 machine hours or less. That is, 0 to 1,000 hours requires 1 person, and 1,000 to 200 hours requires 2 people, and so on. For this question, we need graph F. Number 8, cost of direct materials used, assume no quantity discount. We're going to use graph K. And the last one, rent on a manufacturing plant donated by the country, where the agreement calls for rent of 100,000 to be reduced by $1 for each direct manufacturing labor hour worked in excess of 200,000 hours, but a minimum rental fee of 20,000 must be paid. For this one, we use graph C. So that's how we answer the question and the graphs.